Before we're going to start with node timber and go into the structural calculation of timber constructions, I'd like to show you something about code and design and data, difference between code and data. Usually if we, for example, take Excel, then you have the code integrated into the data. So let's say we are going to try to calculate the area of something with an A and B, take it as the length and the width of an area, and you can calculate the area of this part by multiplying these two values. This could be that the code in this case is this cell, which says that you should take the multiplication of these two values. So we can save this program if you want to under a name, and say, let's say a couple of weeks afterwards you want to make a change to those calculations because you have a new project, and in this case your client gives you an additional area for free, let's say 15, could be square meters, and you have to change the formula, the code, by adding this new value in addition. So more or less you have a new program now, and the problem in that case is that this new calculation is not compatible to the old one you have. So if you are going to have a change in the first project, you really need to go back and either copy the new code to the old project and manually change these values, or you more or less need to change the code of the old project. So how is this handled in programs? Usually the things that you do have an input file. Here we have a structural calculation. You have an input file and you have the code and the input data split. So you have the data of the project in the input file, and you have the code in the program itself. Both approaches are valid, and both approaches are also possible in Maple. So if we go back to Maple and we create a new empty project, then you have the same thing here. We define something and we can enter the code by multiplying those two values. So Maple in that case behaves exactly like Excel. The code and the data is integrated in one file. You will have the same problems as I mentioned before with Excel in Maple, because the code and the data is integrated. Now if we now open NODEMaple, you will see that the approach I have taken here is a mixed approach. So in that case, the data and the code usually is split, but you can also have it integrated, as in this easy example which I've shown here. We open the first sheet, which is called Material Properties, very simple and straightforward. So you have a project with a project number and a title and a client. These values are unique for that one, and if you're going to save this sheet somewhere else and give it a new name, then it behaves exactly like the Excel or the simplified Maple sheet. The code and the data is integrated in one piece. There is, however, one problem, as 2/3 or probably more than 80% even of the logic of the code are not in the Maple file itself, in the NODEMaple Maple file, but in the library. There is a high possibility that you're going to run into problems. The problem now here is that I'm often do changes in the code, and the functions might have changed in that case. So if you're running these calculations with a new library, it might not work anymore. So it's very important to split the code from the data again. And to do that, I have integrated something which is called the XML import and export function. So we have the input of the project, we have the data, which in that case is very simple, a timber type and a dimension. And the three definitions for timber, which is strength class, service class, and load duration class. And also a list of materials which are predefined in that case. So you, in that case, I have predefined two values, two set of timber materials, and by clicking here and there, you're going to see that this one is changing as well. These values down here, they are calculated values, so they are coming from the library more or less, and based on some kind of calculation, based on the K-mode factor and the gamma m, the material safety factor, you're going to get these values. So to see to export these values and be sure that they are readable afterwards, you can create an XML file. So let's just say, let's call it test XML. I'm going to use that one, and I'm going to make a new file. So let's change that one, and then opening the XML file itself. You'll see that here are the input values. The calculator of the values are also included in that XML file. You might use them afterwards in a different project or even a different program, but the key input data is more or less here: material timber and a name, which also defines a timber type and a service class and a duration class. So more or less, when using the program or these sheets, always try to save your values in an XML file. Even the XML file might be changed afterwards in consecutive versions, because I always make some changes to the code as well. But it is very easy to change the XML file in a format that makes them readable again. So there is both an upwards and downwards compatibility in those XML files. They're human readable and very easy to find out what's going on. So next time we are going to dig a little bit more into the timber sheets in specific, and hope I see you next time.